Hello, honors pre-calc. How we doing? Happy week 8? Is it 8? 7, 8 of e-learning. We can do this. All right, so I know I promised in the last video that these would start getting a little bit shorter. My hope is at least the next two will be. I'm going to try my best to kind of spread these out a little bit. So this one's on the law of signs again, but this is a special case. It's called the ambiguous case. So if you remember from our notes before, we were talking about the law of signs, using it for AAS and ASA. And so these are kind of the two normal cases, and now we have the ambiguous case here. So usually I'm able to just write this case on the board and then we get to erase it and move it along, but here I'll have to record it, and so I hope it gives y'all a laugh. You'll see what I mean. All right, so the ambiguous case is when there's a possibility of having two different answers, meaning there could be two different triangles that have the same or almost the same except for one or two sides and angles. So we have these two possible answers here, okay? And this happens when we have the ambiguous case. So this, I can go through this whole explanation here. I'm not going to go through all of it, but this kind of explains it in the red here. There can possibly be two triangles, one with an obtuse angle and one with an acute angle that have the same sign. So if we remember back to the unit circle, remember sine was the y. And so you can notice that there's a bunch of different angles here that have the same y coordinate. For example, here pi over 6 at 1/2 has y of 1/2. And then also there's this 5 pi over 6 that has 1/2. And so both of those have the same sign. Okay, and so in an obtuse angle and an acute angle. Here's the acute angle, here's the obtuse. Okay, and so it ends up that in the law of signs, based on these different parts that were given, there could be two possible answers or no answer at all. Okay, so we'll get into this. So this happens, the ambiguous case, you always have to check for this when you're given one angle and two sides. Okay, so this only happens in the two sides and an angle not between them case. So here in this picture, we're given angle A, side B, and angle A. I'm sorry, and side A. So we have angle, side, side. Well, what does that spell? All right, ass. There, I said it. You can replay it whenever you need a laugh during this quarantine. All right. But so this is going to happen during the ass case. Okay, I'm just going to keep saying it because I know we all need to laugh right now. So you don't ever need to check this for angle, side, angle, or angle, angle, side. But whenever you have ASS, the ass case, all right, you have to check for ambiguous. And what that means is there could possibly be two answers, no answers, or there could still just be one answer, the same as the regular law of signs. Okay, so let's look at this one here. This is, we're always, because we have angle, side, side, we're going to almost always be looking for a side. I'm sorry, an angle here, but you could be looking for a side. You just have to do multiple steps. All right, so I'm going to get into this explanation below later, but we're looking for angle R. We have the ASS case here, okay? So angle R, remember the law of signs is still the exact same. We're still doing this here, okay? So we have the angle and the side across from each other are what we need. So we're looking for sine of angle R. So we're going to use across from it as side R. So sine of R over 41 equals, and then look at that, that's good. We're given angle Q and side Q. So sine of 39 over 28. Okay, so we're going to solve this the same way by cross multiplying. So we have 28 times sine of R equals 41 times sine of 39, and then we'll divide by 28. That gives us sine of R, and so this we need to evaluate in our calculator. So 41, oops, there it already did the work here just to check. Okay, 41 times sine of 39. And then I'll divide by 28. That gives me 0.92. Okay, I'll just write that here, but when I plug this back in, I'm going to use that whole decimal. So this is the same thing now as the law of cosines. To separate the sine and the r, I'm going to take the inverse sine of both sides. And that should give me angle r. Okay, so this time make sure you're doing inverse sine, not inverse cosine, because we're using the law of sines of, no, I'm going to put in that last answer. All right, I should get 67.1. Okay, but we can't stop here only because this is the ambiguous case. Okay, so again, I don't need to test this on any of the other ones because there could be another option for a triangle. This is the acute option, right? There could also be an obtuse. So if you look down here at this picture, I kind of tried to explain it in a visual. Here is the triangle that we just talked about. Okay, it has the 39, the 41, the 28 that were already up here, and then we just found angle R to be 67.1. But there's going to be another triangle here. Okay, this one also works. We have a 39-degree angle, a 41 side, a 28 side, and then there's a new value for angle R here. Okay, this stems from the unit circle also because when we did this in geometry, you weren't allowed to use the ASS case, right? Because it's not actually a way of proving triangles congruent. So that's why there's these multiple options. All right, so how do we get this other option for angle R, this 112.9? So angle R, basically it's the acute and the obtuse, and it goes back to the unit circle, where when we were talking about this 30 and this 150, well, what's true about them? They add to be 180. Okay, so they're always going to be supplementary, my two options. So because this is 67.1, my other option for angle R is going to be the supplementary angle to that. So I'm going to do 180 minus 67.1. Okay, I'm going to get 112.9. Okay, and so that's where I get these two options from. There is one thing I need to check for. Okay, I need to check that there's room for a third angle to add up to be 180. Okay, so I have an example of that below here, but I just need to check what's 112 plus 39. 112.9 plus 39. Okay, so I get 151.9. What that means is that angle P, right, we're going to have a value, right, because the three angles in triangle have to add up to be 180. 180 minus 151.9. That's going to tell us that angle P is 28.1 degrees. Okay, that's good. That's what we want. That means that second triangle is going to work. Okay, so since 151.9 is less than 180, we have two triangles. All right, I'm going to show you an example of when it doesn't work. But so this gives me my second option for angle R. Okay, but that's not always going to be an option. So we'll just get into that. All right, but for right now, because this ends up being less than 180, there's a room for a third angle. So both of these are options for my answer for angle R. All right, so let's try another one just of the basic type. So here I have B's and C's, so it's likely that I have, triangle ABC. Again, it doesn't matter how you draw it. So I have angle C is 112. Side B is 17 inches. Side C is 36 inches. And I'm looking for angle B. Okay. And so again, what case do I have here? Well, I have an angle, a side, and a side. So I have our AS case. So I know it's ambiguous, right? I know that I'm going to have to check for that second triangle. So here I'm still going to use law of sines. I'm given angle C inside C and angle B inside B, so that's good. I can just plug right in. So sine of B over 17, those are across from each other, equals sine of C, which is 112, over 36. So now I can cross multiply. 36 times sine of B equals 17 times sine of 112. Divide by 36. Sine of B equals, this I can do on my calculator, so 17 sine of 112. And then divide by 36 is 0.44, but again, I'm going to use that whole decimal, okay? So the way that we separate this, by taking inverse sine of both sides, and give us our measure for angle B. So I get 25.96, so if we're going to round that to the nearest tenth, that ends up rounding to be 26 degrees. Okay. So we have to check here for, because it's the ASS case, because it's the ambiguous case, we always have to check for a second triangle. All right, so again, the way that we do that, it's going to be the supplementary angle to the one that we're looking for. So I'm going to take this 26 and find its supplementary angle. So I have 180 minus 26. That's going to give me 154. All right, so that means angle B could also be 154. Okay, but here's what we had to check for before. Is there still room in this second triangle? Now we have a new triangle. Okay, so if we just draw a new triangle, this is our second option. We still have ABC. We labeled angle C was 112. Side B was 17 and side C was 36, right? That's not changing. And now in my second triangle, angle B is going to be 154. All right, here's the problem. This isn't going to be an option, okay? Hopefully some of you are starting to see why, but the reason is because if we add 154 plus 112, right, we get 266 already from those two angles. And so what that means is that there's not room, right? There's no room for a third angle. All right, and so what that means is that this option for angle B is not an option, okay? And so there's only going to be this first one. Okay, so that's what I meant here by checking, right? In this first case that we did, when we checked the new angle that we found for angle R, added to the original 39, was 151.9. That was less than 180. That means we can have two options for triangles because there's room for a third angle. But since 266 is already greater than 180, there's not room for a third angle, and that means there's no triangle. Okay, so there's only going to be that first one that we found. All right, let's try one more of those special cases, and we'll get to a longer one, and then that's it. All right, so here we have triangle PKH. The measure of angle P is 59. Side H is 35. Side P is 20. We're looking for angle K. All right, so the problem here is that we're looking for angle K, but we're not given side K. And so I know I have the P, right? Angle P and side P I'm given. So I could start there, sine of 59 over 20. I know at least I'm going to use that. And then since I'm given side H, I'm going to have to find angle H first before I find angle K. So sine of H over 35. Whoops, I should have checked for the case first. I have angle side side, ASS, our ass case, ha 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 ha. Oh, okay, so I know I need to check for ambiguous here. All right. So I cross multiply to solve for angle H, because we have to get that one first before we can get angle K. Divide by 20. Okay, so I have 35 times sine of 59 divided by 20. All right, 1.5. I'll take the inverse sine of both sides. Okay, quit. Error. All right, why is it doing that? Okay, and maybe some of you, I know I had somebody message me when you were trying to make your Flipgrid projects that this kept happening and come up in a domain. So we haven't fully talked about this yet in terms of our domain and our ranges with trig functions. But basically what's in here has to be less than 1. All right, and so what this means, if you get that, if this, well, this is for sine or cosine. It's not necessarily true for tangent or cotangent, but we're not there yet. So just for sine and cosine, this has to be less than 1, right? We've almost always plugged in a 0.87 or a 0.34, right? They're all less than 1. And so because that's 1.5, right? There's an error here, so that means there's going to be no triangle. This isn't even actually a triangle. There's no triangle that could have this angle measure, this side measure, and this side measure. All right, so that's what that one means. All right, last one here. Again, we have A's and C's and B's, so I have triangle ABC. Angle A is 42, side C is 29, side A is 20, and I'm looking for angle B. All right, so what case do I have here? Angle side side, my ass case. All right, I'll give it to you one more time. So I'm gonna make sure I check to see if there's 2 triangles or no triangle or only 1. All right, so you'll notice here that I'm given angle A and side A. So I'm probably gonna start with that. I know I'm gonna use the law of sines. And I'm looking for side B, and so there's going to be a lot of work on this problem because I'm not given angle B, I'm only given angle C. Okay, so this is the hardest possible option of problem we could have. So good thing I'll go through this with you on the video. So we've got to start by getting angle C before we can get the B's at all. So sine of C over 29. All right, so we have 20 sine of C equals 29 sine of 42. Divide by 20. Sine of C equals 29 sine 42 divided by 20. So that's 0.97. And then take sine inverse of both sides. Get 70, that's going to round up to 76 for angle C. All right, so I know we're going to at least have one triangle here because 76 plus 42 is less than 180. There's room for a third angle. All right, but this is the ambiguous case. Okay, so I need to check, and I need to do it now before I move on to angle B because this is the angle that we solved for. Is there another option for angle C? All right, so I'm going to subtract, remember the same way we were doing before, 180 minus 76 to find its supplementary angle. That gives us 104. So angle C could also be 104. All right, so we need to check if that's going to actually work. The way that I do that is by adding that 104 to our original angle A of 42. That's going to give us 146, and that's less than 180, so that's good. That means there's room for a third angle, for an angle B. So I'm going to have two triangles in this problem. Okay, so if I was just stopping at angle C, we'd be done, but we got a lot more to go here because we're looking for side B. So the only way we can get side B is by first getting angle B. All right, and so if there's two angle C's, there's also going to be two angle B's. Okay, so we kind of just found one here, but if angle B first is going to be 76, right, then we'll have 76 plus 42. That's going to give us 118. And then we subtract that from 180. That's going to give us 62. So angle B, if angle C is 76, angle B is going to be 62. If angle C is 104, then we're going to use this calculation here, right? Remember we already did this 104 plus the original 42, we got 146. So I do 180 minus 146, that's going to be 34. Okay, so that means now we have two options for angle B. It's going to be 62 or 34, depending on what triangle we're in, because we already determined we're going to have two triangles. Okay, last step. I told you this one's going to be a doozy. Now I need to find side B. And here's the deal. If there's two angle B's, there's also going to be two side B's. So I'm going to have to do two of these calculations. Okay? I'm actually feeling a little bit sad right now, but we're making the best because I usually teach this. I miss you guys all groaning. Oh, more? All right, I'll just imagine in my head. Okay, we're still using law of sines. Okay, so we're going to do the same thing. Once with angle B as 62 and once with angle B as 34, sorry. So we don't want to use angle C here because there's two options for angle C. So I'm going to use angle A and angle B, okay? So this original sine of 42 divided by 20. And so this is for the A, and then here's B, because we're not going to use C here. So for angle B, first I'm using 62 over side B. And then I'm going to do the exact same thing. Sine of 42 over 20 equals sine of, instead of 62, this time for angle B, I'm going to use 34. All right, so now we cross multiply. This one's going to be easier because we don't have to find the angle measure here. But so this is B times sine of 42 equals 20 times sine of 62. Divide by sine 42, and that should give us our answer on our calculator. All right, same thing down here. So I'm going to cross multiply just to make sure I'm doing this all together, and then we can plug it in our calculator. 20 sine 34, divide by sine 42. All right, we should get our two answers for B. So in this top one, I have 20 times the sine of 62. And then we're dividing that by the sine of 42. So that gives us 26.4. And remember, that had units of feet. And then I'm going to have another one down here. So that's 20 times the sine of 34 divided by the sine of 42. And that gives me 16.7 feet. And so because there's two triangles, right, we can have two options for angle B, for angle C, and then for side C. So this is the most difficult type because there's so many options, okay? And we actually ended up solving this triangle here. That's what the next video is going to be on. Again, this is still the hardest option, but now you've kind of gotten a preparation for that. All right, your homework is this law of sines worksheet. I will send that out. The ambiguous case. This video wasn't as short as I thought, and my apologies. I'll stop saying that. All right, I hope you enjoyed me saying ass so many times, and miss you all. All right, see ya.